This is House Planning Help, episode 255. Hi there, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build, because I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. And coming up in this session, my guest is Chris Herring from Green Building Store, and we're going to be looking at high-performance windows and how you go about specifying them, some of the technical terms as well, all of that to come. First up, I was wondering, are we covering all the bases here? It's very easy. If you've been listening for a while, you might know that I've gone off in various different directions because I've had my own project to contend with, and that's sent me to find out certain things. But is there anything specific that we can be helping you with? Because that's what this podcast is all about. It's ongoing research. We're going to be busy for a while, so you might as well let me know what's in your mind, and perhaps we can help out, particularly if you're stuck with something. We can do some research on a topic. And I like to, if I can, reply to as many emails as possible. So that's probably the best way for this sort of thing, because you normally find you've got a few things that you want to explain. So if you email via the website, it'll get to me. Just use the contact forms, and then we'll see what we can do at this end. So let's get to my featured interview. Chris Herring is someone who I've come to know over the last couple of years, and it's been a great pleasure. In fact, I love the work that they do at Green Building Store. So we're looking at high-performance windows, which is one of the specialist areas that they deal with. They know a lot about it, and that's why I thought he'd make a good guest. Warning, we have some technical information coming up, and this is actually what I wanted to dig into as well. So I'm half expecting that. I'm never quite sure how it's going to work with audio, whether it will be a good medium to convey it, but we're giving it a go, and Chris certainly doesn't hesitate whatsoever. So if you do find yourself being bogged down by technical detail, just jump forwards a little bit in the conversation and we'll come back again. I started by asking Chris just to tell us a little about what do windows do for us?
I'm not an architect. I've been a practical builder, and I've been involved in windows for a long time. But clearly windows are key to any building. They are really very important in terms of the feel of the building, the architectural feel of the building, how we feel in a building, the amount of light that they're let in. So they're really quite critical. They're not just another building element. They're a really critical one, I think. Yeah.
And what are the different functions that a window will fulfill?
Well, that's the thing that makes them so complex, really, because they fulfill so many functions. You know, you'd say they have an architectural function. They've got physical functions. They're part of the fabric. They're part of the thermal envelope. So they've got to have sort of thermal performance. You've got to be able to get out of them. You've got to let light into them. They're sometimes protecting against fire. There's so many, there's safety issues. And what you're doing in specifying windows is bringing all of that together, and they're often in conflict. So architects will want often fashionable to have very large areas of glazing. People want to see big vistas from their buildings sometimes, or architects just like the feel of it, and then that's in conflict with function. So you might result in overheating, or you then need more expensive provisions to make the windows work because they're so much bigger. So the functions don't all work together, and we have to compromise and get the best we can for anybody specifying windows, really.
So as a self-builder, is our first cue coming from the architect or designer, or if we're doing that ourselves, is that where we will begin on the selection process?
I think you will. I mean, it's obvious that your architect is going to be very important to you, that they're your advisor, and they're designing your building. But I think it's very important now for all building components that manufacturers or suppliers are a key part of the design process. As buildings become more complex and the components become more complex and the performance levels become more complex and difficult to meet, I think it's going to be suppliers, manufacturers who actually provide more of the information in some ways, so become more part of the team. And what we see is, particularly on complex jobs, on non-domestic jobs, where that supply chain isn't properly sorted out, I'm actually dealing with one at the moment, it becomes very chaotic because the manufacturer is not able, or the supplier is not able to really support the best solutions because they're tendering. So they're not in the contract. They can't bring their knowledge to it. So I think what I'd like to see in the future, and what I hope we'll see in the future, is product suppliers who add a lot more, which is what we try to do at Green Building Store. That's what we see as our role, is to help people to specify windows well, in the case of windows, so that they understand what they're specifying. We'll work with architects, and the more we can work in partnership, the better I think the building will be.
As I think back to that part of the process when I did my own build, I certainly remember that perhaps out of the whole building, it was the most complex, both checking window schedules and numbers and measurements, and you're not convinced 100%. So I think we've got a lot to dig into here, but I'd like to attempt to go technical on some of these things and just look at a few of the terms that surround high performance windows, because I think really this podcast that we're generally interested around that. Is it worth just talking about the difference between double glazing, where we started, maybe single glazing, and how we've arrived at triple glazing first of all?
We've seen an incredible evolution in windows in the last few years. I mean, in the 80s, when I first came into building, so early 80s, we were fitting double glazing. We were fitting fairly minimal double glazing, and we thought that was okay. Now, I would never fit anything but triple with big cavities. It's there's a huge step, and we've jumped there from typically U values in windows of around maybe 4 to U values of below 1. That's a massive jump. And okay, the industry isn't quite there. The industry is in sort of 1.4 or something like that. I can't just remember the building regulations now, but in that area. But nevertheless, even that is a massive jump over 30 years or something like that, just over 30 years. So there has been a big evolution. And I don't think actually that the industry has properly caught up with that and understood the implications. I mean, particularly in terms of issues of overheating, of course, which are very big for buildings.
Well, maybe we'll come on to that a bit later. Is comfort a big driver of high performance, really? Because that's the benefit at the end, isn't it? Are there any other key benefits? Because that one's huge.
That's quite difficult to answer in a way. I mean, the whole thermal envelope is key to the performance of the building, and fundamentally that's about carbon emissions. So, we've got to make energy efficient buildings. I think it's just a given. There is no point building buildings and just building them badly. This is what we fundamentally do. You've only got to tweak it, as you know, Ben. You completed the passive house with a little bit of attention to detail and a little bit of extra skill. You can make a building that's much, much better. And triple glazing you need, if you just look at the simple logic of the building, you need triple glazing to make that work in this climate. So it drives you there. Having said that, obviously comfort, once you passive house levels of performance, comfort is absolutely key, and it's a key selling point. Obviously, it makes buildings more comfortable as well as more energy efficient. So the windows as part of that package, as part of a system, really. They don't stand alone. It's that sense of we are looking at buildings as systems, and they're actually complex systems. So we need to put the window in that context, really. So we need triple glazing because the passive house standard drives us there, and it drives us there because the building physics drives us there. I mean, the key to that is in many ways comfort, because we need every surface to be warm, because then we don't need to heat the building very much. So as soon as you get a cold spot, you're going to get molds, you're going to get discomfort, you've got downdrafting, you've got all these problems. So the system stops working. So it's the building as part of the system drives us to triple glazing in this climate. If we lived in northern Italy or something like that, we probably wouldn't. We'd be double glazed. It depends where we are, what the system demands, if you like.
So let's look at some of these terms. First of all, energy balance.
This is the difference between the window and anything else in the building, obviously. Everything else is just about energy loss, fundamentally, or stopping it. But with a window, it's very different, because what we're looking at is we've got obviously energy loss, and we've got more from a window than any other part of the fabric, because our technology is not that good. In the end, glazing is amazing. I was just staring at a piece of glass the other day and thinking it's quite stunning, And before we had glass, and when the invention of glass, it must have been absolutely revolutionary. We had windows with just shutters and openings, or windows with paper, semi-opaque coverings, and to have glass where you could see through. So, windows are amazing. But nevertheless, the technology we've got now, which is the mature technology at the moment, and not likely to change, I think, for the next, I wouldn't like to say how long, but let's say the next 20, 30 years probably, gives us these sealed glazing units. We've got U values, we've got thermal transmission that's a lot worse than the fabric of the building. So that's the sort of starting point. Windows are always going to be a weak point, except that they also bring heat into the building, the solar gain into the building. So that balance between the gain and the losses is what's so significant with windows. Now, obviously, if we're north-facing, you've got no significant energy balance, it's just loss. So the logic is you want smaller windows, because then they're pure loss, they're pure weak point. But other aspects, you've got the balance there. And again, what Passive House looks at is that balance. How do we get the best balance? And again, triple glazing gives us the best balance generally in this climate zone.
U values, lambda values, and G values. Does one lead on more to the other, or how would you define these terms?
This is the thing where how far do you want to go in terms of understanding, and how far do you just want to be led by a supplier? So people can dig into this and really try and get an understanding. We teach quite a lot about these values because they're tools. Without them, you don't quite understand how the performance is working. So then you're taking somebody else's word for it. If you've got some tools, if you understand a bit more, you can make better judgments. I still think you need to take advice, because a little bit of knowledge can be a dangerous thing, as we know. So let's just look at those a little bit. So we've got, very simply, we've got a piece of glass in a frame. That's what a window is. There will be a heat loss through the piece of glass, and we give that with a U value. So that's a heat loss per metre squared per degree Kelvin difference between the inside and the outside. So watts per metre squared, K. We can do the same thing with the frame of the window, which will be very different because the heat loss through the frame is different from the glass. In fact, it's usually worse than the glass. The glass now is better than a thin, imagine a thin piece of wood or a thin extrusion of PVC compared with a wall of a passive house with, say, 300 millimeters insulation. It's obviously a lot worse. So the U values, typically frame values, are one of the real weak points. And of course, the glass, you've got solar gain, and the frame, you haven't. So all those things to consider. We've got an extra little element, which is a psi value, which is the heat loss through the edge of the glass, effectively, where the glass meets the frame. And we give that a linear value, so that's a heat loss per metre perimeter of the glass. And we add those three factors together, the frame value, the glass value, and the psi value, the edge of the glass, and that gives us the U value of the total window. And each window will be different, obviously, because you've got a different proportion for a different size window, different proportion of glass and frame. So every window will have a different U value, which is why in passive house methodology we don't really talk very much about the U value of the window, except for sales work, so people can compare windows. But what we look at is those three values, and we plug them into the passive house planning package, so we can each window is modelled separately in passive house planning package. That's something we don't do in UK methodology, where we actually just use a crude U value for the window, standard window, which makes it very inaccurate. The next thing to consider is obviously the solar gain. We talked about the energy balance, and that's given by the G value. And the G value gives the proportion of solar gain that actually gets through the glass. The more panes of glass and the more coatings we put in there, the more you restrict the amount of sun that can get through the glass. So the typical G value, so a percentage of solar gain getting through the glass in a triple glazed window, will be usually in the sort of 50 to 60% range. It might be just above 60, it might be just below 50, but it could depend exactly on the configuration of the glass, but it'd be in that sort of range. If we had a double glazed window, we might be at the 70%, and if we had single glazed, we might be at the 80 or 90%, but the balance would be worse, because obviously a lot more heat loss. So we're looking at balancing them all the time. So that's the G value. Lambda value is thermal conductivity. So this is a little bit harder to get here. This applies to every material, as U values do. So it's actually the inherent quality of the material. So obviously if we take a piece of aluminium or a piece of, expanded polystyrene, they've got very different amount of thermal conductivity, the amount of heat that can get through per metre thickness of that material. So a lambda value is given as the heat loss, which is given in watts, per metre thickness of the material per degree difference between the inside and the outside. So that's watts per metre K. So the metre is the thickness of the material. So it's quite different from the U value, which is about an area value, if you like, it's per metre squared. And we'll use that thermal conductivity to then calculate the U value.
That's obviously, we're going into quite a bit of detail. We sometimes limit ourselves on the podcast, but I did want to cover that. Let's just rewind a moment to PHPP. So what are we putting in around those windows? Yes, every window is modelled individually, but to do with all of those different values, etc., I don't know whether this is easy to describe off the top of your head, but
it's quite simple. I mean, actually, there's a standard calculation. There's a formula for calculating, which says simply adding up, as I said, the heat loss from the glass, the heat loss from the edge of the glass, heat loss through the frame. Just add them together. So that's the calculation. It's done to a European standard, EN 10077, Part 1 and Part 2, which I don't remember many of these, but I remember that because it comes up fairly regularly.
It seems impressive.
It always feels impressive, yeah. So that's a simple calculation. What PHPP does is simply does that calculation. So we put in the U value of the frame, the U value of the glass, the psi value of the glass, and we calculate that for each window it calculates the total heat loss, if you like. And it does give us the U value of the window. That's not important. What's important is the heat loss through that window. It builds in one more thing, which is another psi value for the installation. Now, this is an area that we don't, well, certainly the industry in the UK is not conversant with. When we install a window in a wall, we've obviously got a U value for the wall, which is fairly uniform. A wall is obviously given things like timber studs, but fundamentally we can take a U value for the total wall. We've got a thermal loss through that window, which is to say we calculate in the way I've said. But then there's a little bit more, and that little bit more is the detail of the installation, the way the window is actually inserted in the wall. This is not about air leakage or anything like that. It's physically the amount of heat loss through that junction. Generally, there will be some heat loss, and again, that heat loss will be given as a linear value, so the heat loss per metre perimeter of the window. That's another psi value, and again, it's given in watts per metre K. To get the installed value of the window, we add that heat loss to the total heat loss of the window. This is something we don't do in UK methodology, and in passive house methodology, it's given a lot, the installed value of the window, because that is actually more important. If we lose that psi value, that installation value, into the fabric of the building, which is what we do in the UK, we fudge it into the rest of the fabric, we don't realise the implications of installing the window badly. So getting the detailing, making very poor detailing. And we can take a really good window with a U value below 1, say at 0.8, we install it well, and the installed value would also be 0.8. We'd have effectively an installation psi value of 0, so nothing to add. Or if you install it badly, we can be up in the 1 point something. So in effect, we can install a nice triple glazed window at 0.8 and end up with effectively what would just be a double glazed window. So we throw our money away by installing badly, or we don't get good performance, whichever way you want to look at it.
Having built a masonry passive house, and you get to see almost the difference of trying to keep that continuity of insulation, because that's a big thing, isn't it? That a lot of the time the windows will be in line, traditional buildings I'm talking about here, with the masonry perhaps.
Yeah, I think that's right. I mean, if we imagine that detailing, if we take a traditional cavity wall with an internal and external skin, and we put the window in the external skin, we've got a massive thermal bridge there. We've got a massive source for heat transmitted as a result of the way we've installed. If we install the window in line with the insulation, then that thermal bridge will be minimised or eliminated, in fact. And yet we won't be aware of that with conventional building in this country. Whereas we're building passive house, we'll have modelled that because we're forced to. We'll know exactly what the influence is, and we will know much more accurately what the performance of our building is. So that detailing is incredibly important, and something people struggle with, and architects struggle with. We see it all the time. And it's something now actually in our company, we offer that detailing for free because we think it's so important that people get that right, and we'll model it for people as well. And I think, again, coming back to what suppliers or manufacturers offer, I think this extra value of supporting people further, of supporting architects or supporting clients, I think it will become more and more important for suppliers to add those extra values to supply. It's not just a widget that's somebody else's problem, how they fit it. The supplier should be going further down the chain and advising people how they fit it and helping them to get that detailing right.
Is there anything else we need to know in this conversation that needs to sort of round it off today?
I think there are a number of, things that come to my mind that are useful for people to be aware of. One of the big issues in low energy buildings and passive house buildings is overheating. Now, if we model in PHPP, we're going to have a fairly good idea of the overheating. It's not foolproof. It gives us the overheating for the whole building. It doesn't differentiate in different rooms, things like that. So we need to come at that also with intelligence. And there are some simple tricks. Obviously, overhangs make a huge difference. But there are other things, for instance, full height windows. If we think about it, this is an interesting aspect. If you take a window down to the floor, it doesn't increase the light level in the room very much because you're only lighting quite a small area. Your light is coming into a small area of flooring, if you like. It's the higher light that has more effect in terms of lighting the building. However, it will result in increased overheating. So, because we're still heating the floor up fairly close to the window, and that's heating the room up. So, if we can certainly be aware that full height glazing is more of a risk in terms of overheating. So, an overhang to shade a full height window will need a much bigger overhang. We probably haven't got that. So in that case, although our overhang can be shading the top half of the window, the bottom half, going down to the floor, is not shaded and therefore is resulting in overheating. Now, we might want a full height window because we want it architecturally, or we want to be able to see our garden in full or whatever, that's fine. But understanding the design implications of what we've chosen is important. And generally, we find that designers are not aware of those sort of things. So tricks like that. Another one would be very simple, thinking about the implications for safety glazing. So if we've got a window in our regulations that's above 800 from the floor, we don't need safety glazing. It cuts the cost quite a lot. So there's quite a lot of things that we can help with as a supplier. We will take you through all those aspects, both performance aspects and regulation aspects, to help you get best value.
And in terms of self-builders who come to you with questions, are there any common questions that come up that might be worth just mentioning here as well, so we wrap up?
One of the questions is always around double and triple glazing. Do I really need triple glazing? Because it's culturally not, we're not used to it in the UK yet.
But that sounds like you're rewinding the conversation quite a lot there. That's interesting.
I am. Okay. But in a way, that is one of the fundamentals that people will come to. Now, they tend to come to us for triple glazing because that's all we do. We made the decision some years ago that that's what we would offer. I suppose another question is around the use of aluminium cladding, actually, in windows, which is where people want to go to timber. We don't really engage very much with the conversation around PVC windows, for instance. PVC windows will give perfectly good performance. We can go to passive standards of them, they're fine. It's a very controversial area, whether the environmental impact of PVC, all of the work I've seen, all the evidence I've seen shows that PVC is very environmentally damaging. So we would only offer timber windows. We don't engage that much in that conversation because people will have chosen to come to us because we have timber windows mostly. But we do engage quite a lot in the conversation around whether to aluminium clad windows. And I think that's probably the largest area of discussion that we might have. It's an interesting discussion because aluminium obviously has a very high environmental impact. I mean, the energy used in smelting aluminium, certainly in virgin aluminium, is very, very high. Even recycling takes quite a lot of energy. And there's evidence that if we increase the use of aluminium, we're actually drawing more virgin aluminium into the supply chain because the recycling is at a certain level and it doesn't decrease that fast. So I think we are increasing the environmental impact of a window by adding aluminium cladding. The other misunderstanding, I think, in that is the nature of modern paint systems, which are quite different. People are frightened about painting windows, and because the experience from the 60s and 70s in this country is of appalling windows with appalling paint systems, modern paint systems, factory finish systems, are just a world away from that. And in many ways, you can regard them as plastic cladding of windows, really. So that discussion is quite difficult. We've always tended to encourage people to go to non-aluminium clad windows because the evidence seems to show that lowers the environmental impact of the window. We have sort of bowed to demand, if you like, and now offer an aluminium clad as well.
What's interesting, because I went for aluminium clad, and I must admit I did not think about the environmental performance particularly of that. I was just caught in this conversation, but quite a few manufacturers, I don't know whether this is true, they tell you that, if you go for timber, they'll all rot over time if you're not 100% with the maintenance.
Yeah, I mean, you need to maintain a painted window. I mean, you will need to paint it after 10 years. If you add up the cost of that painting, it's probably going to be quite similar to the aluminium cladding. What they don't tell you with aluminium cladding is that it fades over time, and you will lose the appearance of your building over 20, 30 years. Depends how long you think the lifespan of your window is going to be. It's a complex balance, and I'm not saying you made the wrong decision, Ben. But most suppliers won't even discuss that with you, really. We will, and we won't push it down your throat. I mean, if people come to us and they ask for aluminium clad, we'll give them aluminium clad. If they want to discuss the issues, then we'll certainly discuss that with them. And we do outline some of that information on our website as well, so people can think about those issues.
Well, Chris, I think we have covered a lot of ground, so we should pat ourselves on the back today. Thank you very much for your time.
You're welcome, Ben.
Head online to take a look at the show notes for this one at houseplanninghelp.com/255. You can review the key points once again. We've got a couple of diagrams to help illustrate those various concepts that we've been talking through. That'll help you make more sense of it. If you've got a comment or you'd like to ask a question, just scroll down to the bottom of the show notes. We'll link you to Green Building Store, point you to them on Twitter. I think Chris is on Twitter as well. All of that, houseplanninghelp.com/255. Couple of bits of business to finish up on today. Firstly, an iTunes review. This is from Jeff SZT, who says, over the years, I've listened to every single one of Ben's podcasts about self-build. If you're thinking of building your own home, then this is the podcast for you. He has some great guests that are experts in their field, and it's been amazing picking up knowledge as Ben has also been on his own journey of learning before successfully completing his own project. Very easy to listen to, and if you're serious about self-build, you can dip in and out of the hub to obtain more information from real examples. Essential listening. Jeff, thank you so much, and just incredible to think that you've been on that 7-year journey with me, all those podcasts. This is a great way to support us, actually, by just writing an iTunes review, signposting the way. Someone else will find us. Someone else will then read what you've written, get a gist of what it is that we do on this podcast. So it's much appreciated, and it just helps us get in front of more eyeballs. Finally, a quick hub update. What is the hub, I hear you ask? Well, think of it a bit like a self-build boot camp. We continue the learning and get you prepped up and ready to go. No press-ups, no weights around here. In fact, just a load of videos. Does that sound like a boot camp? Not really, does it? It's digital tools to get you in shape, and we're constantly adding to the mix and trying to make it work better so that you get those learnings sooner. So you invest your time and hopefully come away with some big takeaways that you can apply to your own project. For example, we have our in-depth video case studies, and the latest episode to go in. This is my masonry passive house build. We're still on the superstructure. This time round, we're actually looking at what could potentially, I suppose, be thermal bridges if the design and construction hadn't been sorted out, but it has. So we look at a 2-part window lintel. Also, being terrible customers, we wanted a big open plan living area, and that means we need to use a dreaded steel. But how exactly do you get that into the superstructure without then causing a thermal bridge? So that's what we look at in this video. I also catch up with Kieran, who is Mark, my contractor's right-hand man, and find out what exactly does he do in his role. We've also got another conference call that we just put into the archive. This is our one from the ACB conference, where we tried to find out what knowledge that the ACB has accumulated over the last 30 years could we plough into our self-build projects. We had a chat with Alex Baines, who is another one of our in-depth video case studies, and so you can check out that as well. Other features in the hub, we've got our courses, which try to lay a trail for you step by step, and the forum where you can interact, ask questions, and also keep a little log of your own project, particularly if you're finding I'm not getting anywhere. Well, at least if you do this, you can help to realize you are getting somewhere. You're somewhere in the process. Just got to keep on going. If you want to find out more about the hub, houseplanninghelp.com/join. There we go. Another one sorted for another day. Thank you so much for listening. The House Planning Help podcast is produced by Regen Media, content that matters.